Okay, let's look at a couple of application problems involving order of operations in hopes that we can be all done with this and just know that we're comfortable with it and we have an idea of what we're doing with it. And if you're not, that's okay too. It just means you got to practice it because, like I said, knowing your order of operations is really, really important to your overall success in doing any kind of math. Okay? So we got a geometry problem here. It says write an algebraic expression to represent the area of the triangle. So we're going to do that first, then evaluate it to find the area when h is 12 inches. All right, so the algebraic expression, in other words, they want us to use that term and that expression right there. So if you remember, it's 1/2 base times, I'll just write it out, 1/2 base times your height, right? Is how you figure out the area of a triangle, because if you drew it as a rectangle, right? If you drew it as a rectangle, it would be just, you know, your width times your length here, and then it's half of it because you're not including this part of it, all right? And so that's where that formula comes from. So you have 1/2, your base is that h plus 6, and then your height is just h, right? So you have 1/2 h plus 6 times h. All right, now it says, so I'm happy with that. I think that looks okay. Then it says evaluate it to find the area when h is 12. So we're just going to rewrite this and we're going to substitute in 12 for h. So we're going to go 12 plus 6 and then 12 right here. All right, so PEMDAS tells me I got to do this parentheses part first. So I'm going to do 1/2 times 12 plus 6 is 18, and then we got 12 here. And then I'm going to try something a little different here. And what I'm going to do is I'm going to switch the 12 and the 18 around. And normally I would just do this in my head, but I'm going to show it to you because you don't want to get inside my head. That's a scary place. So let's do 1/2 times 12 first. All right. Remember, that's the same as 12 divided by 2. So 1/2 times 12 is 6. Then you have 6 times 18, right? Well, 6 times 20 is 120. And then if there's 2 groups of 6 that we're missing because we want 18 groups, not 20 groups, 2 groups would be 12. So it's 120 minus 12, which is 108. And so I get 108, and then my unit would be squared inches because it's area. Okay, one more. One day, 28 small, 12 large merchant spaces were rented. Another day, 30 small and 15 large spaces were rented. Write and evaluate an expression to show the total rent collected. All right, so let's do the first day. All right, so on the first day, it says 28 small, so there were 28 small and then 12 large merchant spaces were rented. And I know that we add those together to figure out the total revenue from that day, right? The total rent. But it's 28 small ones at $15 a day. So if you have 1, it's 15 bucks. If you have 2, it's 30. So that means you're multiplying that 15 by how many spaces were rented. So 28 times 15 plus 12 times 20, because the large spaces are 20 bucks. And then on the second day, right, or another day, but we'll just call it the second day, it says 30 small, and I know now that that's at 15 bucks a day. And there were 30 of them, and then 15 large ones. So obviously, a few more spaces were rented out that other day. All right, 15 times 20. And so pretty much if I'm going to write and evaluate an expression to show the total rent collected, what I'm doing is I'm just adding everything up. I'm going 28 times 15 plus 12 times 20 plus 30 times 15 plus 15 times 20. Now I'm gonna do a little moving around here. What I'm gonna do is I'm gonna kind of show you what I'm gonna highlight the 15s with red, and then I'm gonna highlight the 20s, the ones multiplying by 20, in that day glow green. So let's do the reds first, and let's put them by each other. All right. So we have 28 times 15 plus 30 times 15, and then for the other ones, you have plus 12 times 20 plus 15 times 20. Now we're going to do a little trick here. And I like doing things like this because I think it makes math a ton easier if you can learn how to do this. All right, so first thing I'm going to do is I'm going to recognize that I'm multiplying by 15 in this one and I'm multiplying by 15 in this one. Well, think about the distributive property, right? Distributive property states that if you have something on the outside of a parentheses, you multiply it by both the things inside. Well, that would be the same as if I had 15 times 28 plus 30. Right? And if this is blowing your mind, then you can stop the video right here and you can multiply everything together and multiply everything the way it is and then add it all up and see if you get to the same thing I do. But this is for the people who are interested in learning some time-saving measures and just getting some better number sense. Similarly, with the ones that are multiplying by 20, it's the same thing. If I pull that factor of 20 out of both of them, I get 12 plus 15. And then what's nice about this is if I simplify what's in the parentheses, I only have 2 multiplication problems then that I have to perform. And I like that, as opposed to 4. Okay, so plus 20, and yeah, I did a little maneuvering around. Sorry, I'm trying to dash my 7, but that's not going very well. So 20 times 27. So what I'll do is I'll go 15 times 58. I got to find my calculator. Okay, so we'll go 15 times 58 is 870. All right, so my red is 870. And then my green is 20 times 27. Okay. That's 540. All right, and then you just add them up. So you got 870 and 540, and I think I'm tired of going back and forth, so I'm gonna just add 870 and 540 up right here. 0, 11, carry 1, 14. So they made a total of $1,410 or $1,410 in those 2 days, which is, you know, pretty nice if you think about it. So I hope these problems kind of show you the necessity of being able to work with numbers and move them around and not be scared of them in different representations. And the order of operations is kind of like our universal code of why we follow a certain order, because I want to be able to get the same answer to a problem that somebody in China does, right? So, and that way we all follow if we all follow kind of the same mathematical code, then we'll be able to represent things in a way that makes sense to everyone. So that's why we have this. Think of it as like a shared mathematical language. All right, so good luck with these, and we'll see you in the next lesson.